Hey, welcome to Physics with Sean. Let's do another practice problem. In this problem, we want to find the tension in each cord if the weight of the suspended object is 7 newtons. Whenever working with problems like this, I find it's incredibly important that we simplify things visually as much as possible. So I'll draw out a free body diagram, which will allow me to more easily label things and think about how to solve the problem. And remember that for these types of force balance problems, we want to consider the equation force equals mass times acceleration, or F equals ma. And on top of that, for a system that is static or not moving like the one we have here, we can consider the acceleration to be 0. And on top of that, we can think about how the acceleration of the system must be 0 in all directions, in this case in the x and y directions. So let's start by considering the x components of the forces in this system. I'm shifting things around a little bit, changing the angle labels here. It might be a good idea to check this on your own to see that the shifting makes sense. But we'll consider the x component of the first tension force, T1. And since it's going in the negative x direction, I'm going to make sure to include the minus sign here and just do a little bit of trigonometry to get the value. Then I can do the same thing for the second tension force, T2. And this time we don't have to do anything with the weight of the block since its force vector has no x component, it's only pointed downwards. Same thing can be done then for the y components of these force vectors. First, for T1, we're going to notice here that the component is actually pointed in the downward direction, so we have to consider it as negative. Then T2, positive this time. And lastly, this time we do have to consider the force that the weight is exerting on the system, since it has a downward force, it has a y component of force. And so we'll include it here, making sure that we consider it as negative. And at last, we just have to notice that we now have two equations and two unknowns, T1 and T2, which means all we need is just a little bit of algebra, and we're able to solve for both of those.